So in most cases for safety, it's a good idea to have a look at your model to make sure that there's nothing in the model that's going to cause us any problems, that there's nothing running into any water lines that'll make a sprinkler system for us. There's nothing running into one pattern into another. So we have a couple of tools in the software that will help us out with this. I'm just going to change my shading light here, and I'm going to put my background back to white just to make things a little bit easier to see. So if I come up to our tools, the first tool that we have is that I'm going to use today is the one that we call Waterline to Drill. And basically what this does is, of all the patterns that are inside of this model, the anything that connects to a water line that's not a water line needs to be detected. So when I do that, I'll tell it I don't want any other types of drilled holes within a 1/4 inch of any water line inside of the job. I say okay, and the first thing that it does is it comes back and it says, yeah, there's definitely some problems here. My display is not quite showing it the way that I would like. One sec, I'll just turn the shading back off. And we'll go back. So here you can see that we've taken the actual water line and we've ballooned it out by a 1/4 inch, and we tend to sweep the radius around the end, which will help us a little bit. And I can see that this other counterbore is interfering with this one, but it's closer than my 1/4 inch, but not really causing a problem. I go to the second one, I have the same situation. Third one, here we can see that screw hole that really intersects the water line badly. This would be enough. I think there's one more of these in here. Yeah, so there's one more of the same right here. And what we would probably do at this point is we have a button here to save to IGES. What it'll do is it'll show all the interferences into an IGES file. The CAD designer can load it back up, and it'll show him exactly, when he imports the IGES file over top of his model, exactly where the problems are that we found. So we'd probably send this one back to engineering to get that fixed up. The second one that we can do is we can see if there's any water that's too close to the surface data. So maybe a water line is close to breaking through, and we want to be careful with that. Same with any kind of drilling. So we can do this with water lines or with oil lines. We hold them separately. Obviously, water and oil don't mix well either, so we need to make sure that they stay separate. So I'll use my second tool here, which is Waterline to Model. And for this one, I'm going to tell it 3/4 of an inch because I'd like to stay back a little bit further from my job. And what I want to compare it to, if we have a look at it, it's a little bit easier to see shaded. So I prefer that I pick the colors that I want. So I want to check to that green surface, and I'd probably also like to check to this light blue surface to make sure that everything is as it should be. And it'll take a minute to do the calculation on that, and I probably need to back down my shading just a bit. But basically what you'll see is you'll see that there's a water line here, and we've ballooned around it, and this little yellow leader will show me the closest surface to it, and this will show me the distance to it. So I can just toggle through these and see if there's any in here that cause me any concern. This is a very common problem in design. They don't always have good tools to determine if all the water lines have been drawn correctly. Most of these are harmless, right? So this one here looks like it's a little bit close to that corner radius, but we're still 1/2 inch away, which is fine. Same thing here. And we just go through the 10 of these and we're happy. Same thing, if we need to send it to the CAD department to get it fixed, we would just simply make an IGES file on that button and send it off.